Welcome to part 4 of our C# tutorial series. I'm Eric Wise from Foundry, where we teach people how to code the right way. And today we're going to be talking about expressions in if-else statements. So let's dive in. Now, an expression is a sequence of operators and operands. Operators indicate what action or operation to perform. The operands indicate what objects or values to apply the action to. Now, this definition throws people off a bit because when they think of operators and operands, they usually think of math similar to this. Int C equals A plus B. Now, this statement is actually two expressions. We have A plus B, where A and B are the operands and the plus symbol is the operator. And then there's also a second expression, C equals whatever the result of the first expression is. In this case, it would be 15. So C and 15 are the operands, and the assignment symbol equals is the operator. Just like in math, operators have precedence, which means their expressions are evaluated in order. What catches beginners by surprise is that the highest precedence, the primary operators, are executed first. But this is sensible, and for a good reason. Consider this. I might say C equals int.parse console.readline. Now, object members such as methods, properties, fields, and array indexes are all considered to be operators for evaluating expressions. Because of this, the expression console.readline is evaluated, and then the result is passed as a parameter to the second expression, int.parse. And then that result is passed to the third expression, which assigns the value to the variable C. Now let's move on to the if statement. The if statement is the most common way of making a decision in a program. Decisions are frequently made in programs. For example, is this user logged in? Do they have rights to do this? Does this account have enough available balance to cover the transaction? Is this invoice overdue? Because conditions are Booleans, it means that we must be able to break our decisions down to yes/no answers for the question that the computer is faced with. Let's look at the basic format of an if statement. Now, conveniently, C# uses the keyword if to start, followed by parentheses. Inside the parentheses is where we put our condition. A condition can be anything that evaluates as a Boolean, such as a math expression, like x is greater than y. It could also be complex expressions, like x is greater than y and y is less than z. Or even a method that returns a Boolean value, like a method determining whether a book is available. You can put as simple or complex of an expression as you like in the parentheses, so long as the end result is a Boolean, true or false value, when it is finished evaluating all of the expressions. Now, immediately following the parentheses are the curly braces that contain the code block. This is where you put one or more statements that you want to execute if the condition is true. And let me repeat that. The code in the code block will only execute if the condition evaluates to true. If the condition is false, the code block statements will be skipped, and the program will jump to the next statement after the code block. Now, take note that there is no semicolon after the curly braces. If you go back to our previous tutorials, I mentioned that statements either end with a semicolon or a code block. The if statement is an example of a statement that ends with a code block. Now, it's great that we can make a decision to do something when a condition is met, but what about the inverse? What if we want to execute code only if the condition is false? For that, we have the else statement. An else statement must come at the end of an if statement, and it follows a similar pattern, with curly braces and a code block. The code block will only be run when the if condition is false. Take note that an else clause is not required. If you have a situation where you only want to do something if a condition is true, you can just omit the else statement entirely. But then sometimes we need to handle more than two true scenarios. And for this, we have the else if statement. Let's bring up some sample code for this example. As we can see here, we're printing out a letter version for a grade. Now in the United States, we typically score out of 100 possible points, with every 10 points lowering your grade from A to F. We have 4 cases here: A, B, C, and oof. Notice how after our first if condition, the next 2 are else if and give additional conditions. Also notice the space between the else and the if keywords. The cool thing about else if is that you can have as many of them as you want. In our example, we still included a final else as a catch-all for grades lower than 70. But keep in mind that the else statement is still optional. If we don't want to print anything at all for grades less than 70, we could just omit the else. The last thing to know about statements like this is that only the first true condition's code block executes. All of the others are skipped. This means that the order matters. If our grade is a 75, the first and second conditions will be false, but the third will be true and C will be printed. Then the program will jump out to the next statement after the if statement blocks. And this order is important. If we ordered the code in a different way, we could have a problem. Now imagine that our grade was a 95. Well, that is greater than 70, so the first condition would be true, and C would be printed, and the rest of the blocks would be skipped. This is a good example of a logical error, where the code syntax is correct, but when it runs, we don't get the right behavior. The point is, take a moment to think about your data and the order of your conditions, or you might get unexpected results. Logical errors can be very tricky to troubleshoot. In this example, our code would work fine for grades of 70 to 79 and below 70, but any grade above 79 would be given a C. So the code would appear to be correct only some of the time. So now to demonstrate writing an if, else statement, let's write some code to determine whether a whole number is even, odd, or 0. And I already started with the prompt. We're going to get an integer value from the user. And now we can write our if statement. Let's start with the 0 case. If x is equal to 0, then we can print the value is 0. And now our second condition will be an else if. Else if x mod 2 is equal to 0, then we would say console.writeLine, the value is even. And if you've never seen this operator before, this is called the mod operator, or modulus if you're being formal. And what this does, if you remember back in school when you were doing division by hand, and you did something like 5 divided by 3, the answer would have been 1R2. So 3 goes into 5 one time with 2 remainder. The modulus operator in C# gives you that remainder value. And the interesting thing about mod is that if it is 0, that means it's a factor. And anything that has 2 as a factor is even. So that's a neat little developer trick for checking whether something is even or odd. And then finally, in our else block, we will say if it's not 0 and it's not even, the only other possibility is that it's odd. So we would say the value is odd, just like that. And then if we run our application, it will prompt us to enter our whole number. And if I say 5 it will say the value is odd. And if I run it again, and I say 0, it says the value is 0. And if I run it again, and I say 10, it says even. And that's all there is to if-else statements. And like I said, the else is actually optional. This code would work just fine without an else statement, except we would not get the odd printout to the console. So use as many else's as you need. There can only be one if, and there can only be one else. And that wraps things up for this tutorial. I'm going to put a link to the C# documentation, which has a list of all of the operators in C# in order of precedence. This isn't something you have to memorize, it's just an FYI. Take a glance through it, it'll give you an idea of all the things that are possible and the orders they'll be executed in. And now that we understand the if statement, we can make decisions in our code, so our applications are getting a little bit smarter and a little bit more interesting with these baby steps. In the next lesson, we're going to start exploring loops, and when you combine branching and looping with variables and assignments, you can actually start building interesting and useful applications, even if they are still on the simple side. I'm looking forward to teaching that. And if you want to go deep with C# coding and learn professional development skills with the help of exercises, videos, a community, and lots of hands-on practice, head on over to Foundry, join the community. I'd love to see you there. Happy coding.